Paper 1 from the 8-week revision programme. Question number 1. To estimate the answer to this, we're going to estimate each individual number and then we're going to work out the answer. So 207 rounds to 200, 148 rounds to 150, and 49 rounds to 50. 200 times 150, 2 times 15 is 30, and then the 3 zeros included, divided by 50. 1 0 will cancel. 30 divided by 5 is 6, and then the 2 zeros left make 600. It would also be acceptable to round 148 to the nearest 100, which would be 100, changing your answer to 400. Part B. Given that 47 times 235 equals 1145, write down the value of that question. We know that the only numbers possible in the answer are 2, 3 and 5. There might be zeros after, there might be a decimal point, but the numbers have to be 2, 3, 5 because the question states that. If we estimate this answer, we have roughly 1,000 divided by 0.5. There are 2,000 halves in 1,000, so to make this number roughly 2,000, we're just simply going to add a 0. 13 out of 20 is 13 over 20. If we want it as a percentage, we need to have this number over 100, which means we are going to times by 5. So 65 over 100, so that is 65%. For part D, which of the following fractions is closest to 2 over 5? We need to get all fractions over a common denominator and then pick the closest. Common denominator of 5, 15, 4 and 20 would be 60. So 2 over 5 would become 24 over 60 because we have to times by 12. 7 over 20 will become 21 over 60. 1 over 4 will become 15 over 60. And 7 over 15 will become 28 over 60. Now, closest to 24 over 60 is 21 over 60, and therefore the answer is 7 over 20. You could circle it as well to get the correct answer. Question number 2. Enlarge the shape by a scale factor of 2 using A as the centre. Every line has to get 2 times longer measured from this point A. So currently that line is 4 squares across from A. Going from A in the enlargement, that line is going to become 8 squares across measured from A, which will take you to there. If I look at this point here, currently I have to go 2 squares down and then 2 squares to the right. If I enlarge that by a scale factor of 2, I have to go 4 squares down and 4 squares to the right, which gives me that point there. That point is 2 below at the moment. That will be 4 down from there, which gives me that point there. With those few points marked, I'm able to join up those points to create the enlarged shape, which is enlarged by a scale factor of 2. To rotate the triangle through 90 degrees clockwise about the origin, I am going to use some tracing paper. I am going to trace the shape. I'm going to just put a little arrow to show that that is north, and I'm going to mark the origin. If I wish to go 90 degrees clockwise, I am going to turn it so that my arrow is now facing that way. I have turned 90 degrees, and then I would go back over that with my tracing paper and obviously fill in the correct space. To translate the triangle by 8 units to the left and 1 unit down, I simply move the whole shape 8 units to the left and then 1 unit down. Using this point as reference, 8 units across will take me to here, 1 unit down. The rest of the triangle will move in the exact same way, giving the new shape the current position. Indicate with the letter B on the diagram which one of the shapes is shown may be obtained by reflecting shape A in the line y equals minus x. The line y equals minus x goes through here, because for every x value, the corresponding y is minus version of it. If I was to fold the page and see where the reflection happened, I would see that this shape is where the reflection is. Another way of checking To get to the line, I have to go 1, 2, 3 squares up from this point. So when I reflect it across a diagonal, that means I will go 3 squares across in my reflected shape. So B will be that shape there. Factorise 18a minus 27. There's only a number common, and that number is 9. So I get 9 outside a bracket and then 2a minus 3 inside the bracket. If you don't factorise this fully, for example, taking 6 out as a common factor and saying 3a, or not 6, even taking 3 out and having 6a minus 9, you won't get the mark because there is still a common 3. That will not count. B cubed minus 3b. B is the only common factor, and we'll need b squared minus 3 in the bracket. Expanding brackets, so going the opposite way. 5 times 2x is 10x, and 5 times 7 is 35. To solve this equation, I need to get x on the top of a fraction and work from there. Common mistake here is people do 4 times 12, which makes 48. I need to swap the x and the 4, so I get 12 divided by 4 equals x, which gives me 3 equals x. Solving this equation, I'm going to collect the letters on the left-hand side and the numbers on the right-hand side. So 8x minus 4x equals 7 minus 5. 2x, or 4x even, equals 2. So x equals 2 divided by 4. So x equals 0.5. Not 4 divided by 2 because the 4 is coming over and dividing. Question number 4, calculating x, y and z. Angle x, I am going to use an F to show that angle x is equal to 55. To use angle y, I'm going to use a C angle to show that it must be 180 minus 55, which is 125. I know that this angle here must also be 55 through an F there, and also those two must add up to 180. That allows me to work out z because these three angles are in a triangle, so must total 180. So that gives me the answer 45 for y. And calculate the size of each exterior angle in a regular pentagon. To find the size of exterior angles in any regular shape, we do 360 divided by n, where n is just the number of sides. 360 divided by 5, which equals 72 degrees. Question 5. The table shows some of the values of the equation. Complete the table, and then we're going to draw the graph. So, minus 1 cubed minus 8. Minus 1 cubed is minus 1, minus 8 is minus 9. 3 cubed minus 8. 3 cubed is 27. 27 minus 8 is 19. Plot in the graph. So, at minus 2, I get minus 16, which is down here. Minus 1 to minus 9. 0 to minus 8. 1 is on minus 7. 2 is at 0, 3 is at 19, and 4 is at 56. To get the second mark, I need to join this up as a smooth curve. It is not acceptable to draw a cubic graph using straight lines between the points. You have to do it as a curve. Part C requires you to use your graph to solve the equation x cubed minus 8 equals 40. In order to solve this, I am simply going to draw a line across at where it is equal to 40, draw a line down from that point, and where that hits the x-axis is my solution. In my case, it comes out at 3.6. Without the guidelines, you cannot guarantee the marks because they need to be shown as a method. Question 6. If the points are less than 5 centimeters from x, I'm going to set my compass to be 5 centimeters. I'm going to place that on x, and I'm going to draw a circle around that point. Every point within that circle is less than 5 centimeters from x. If I want the points to be nearer to y than to x, I need to use the perpendicular bisector of this line. I'm setting the compass to more than half the length of the line. I'm placing the compass on y and I'm marking it above and below the line. I'm doing the exact same process from point x, and then I am going to join up where those sets of arcs cross. That line bisects it perfectly, so anything that side of the line will be nearer to y than they are to x, so this section here satisfies both. 6b. Calculate the volume of the triangular prism. To find the volume, I need to do the area of the cross section, and I need to times that by the length. Now the cross section in this case is a triangle, so that is 40 times 50 divided by 2, and the length is 1.2 meters. They want the answer in centimeters cubed, so I'm going to change that into 120. 4 5s are 20 plus the 2 zeros divided by 2 times 120. This gives me 1,000 times 120, which will equal 120,000, and we are working with everything in centimetres now, so that is 120,000 centimetres cubed.